Now for my last example, I'm going to sketch the graph of something that's not a line, okay? But I'm going to use principles that we have used for lines. So I'm going to first find the x and the y-intercept. So y-intercept is, again, very easy. You replace x by 0, you immediately see that that constant 1, so the last term is going to be the y-coordinate of the y-intercept. The x-intercepts, I'm going to write intercepts, you'll see, because they're, in the case of a line, you intercept the line more than only once, right? Or maybe never, if you've got something that's horizontal. But in the case of other types of curves, okay, you could have x-intercepts in many places. You could also, you cannot have more than one y-intercept, however. Because there's a single value of y for a value of x. So for 0, there's only a single possible value of y. So you cannot have a curve that would look like this. That's not possible, because you'd have like multiple values of y for 0, and that's clearly not going to happen if you've got y equals some expression in terms of x. So here we have multiple intercepts, x-intercepts. So how do we find them? Well, same as before, we're going to replace y by 0 and solve the equation, and immediately we see that we end up with a quadratic equation to solve. So this is one of the reasons why we've been practicing factoring, solving these equations by factoring. We're going to find the solutions, and with that, the x-intercepts. So I need a product of 3, sum of 4, 3 and 1 will do. So we split our middle term, factor by grouping. And we see that it ends up being x plus 1 times 3x plus 1. So that means x plus 1 is 0, or 3x plus 1 is 0. So we get minus 1 and minus 1/3 for the solutions. So the x-intercepts, maybe let's frame them here. The x-intercepts are minus 1, 0. And minus 1/3, 0. All right. So let's try to put that information into the Cartesian planes. Let's say this is minus 1 here. So there's an x-intercept here. 1 at minus 1/3, 0. So 1/3 would be maybe here. Okay, and 0, 1 is the y-intercept. Okay, so maybe I'll put the coordinates here. So 0, 1, minus 1/3, 0, and minus 1, 0. Now clearly I need more points to figure out what's going on here. So maybe just for this example, we're gonna replace by some value. So I've chosen values. Minus 1, 6 is just right there, and maybe a few more. So minus 4, 6. So that would be minus 2/3. It's right here, and minus 7, 6, which is just a little bit after minus 1. So over here, and I calculated the y values. So you replace in this equation here, right? In this equation, you replace x by minus 6, minus 4, 6, and you calculate the y values. And you're going to get 0.416 repeated, minus 0.3 repeated, so that's minus 1/3, by the way, and 0.416 repeated. Okay. So, so minus 6.416, so we'd be roughly here at minus 4, 6, we are at minus 1/3, so roughly here, and we're back up at 0.416 repeated afterwards. If we'd have more points, we would actually see that the curve looks like this, and it reaches its lowest point exactly at minus 4, 6. So this is what we call a parabola. So what's a parabola? It's not any curve that looks like this. It's actually a curve that's obtained from an equation of the form y equals a polynomial of degree 2. So if you've got here a polynomial of degree 2, then you're gonna get a what we call a parabola for its graph. So okay, so a parabola is just a graph of a polynomial of degree 2, and there are some interesting features for these parabolas. In particular, if you've got X-intercept, this is called the vertex. This is the lowest point. You could also have parabolas that are like this. You could have like highest points. I'll tell you how you know whether it's concave up or down. If it's like that or like that, I'll tell you how you tell. So this vertex is always halfway between the X-intercepts, and that's only true for a parabola. So if you've got some other curve which has X-intercepts, it's not always true that there's the lowest point in between those. Okay, it's only true for polynomials of degree 2. So if you've got an equation like this in general, okay, this A here decides whether your graph is going to be concave up or concave down. So concave up occurs when A is positive. Concave down when A is negative. So the fact that we have a 3 there tells us that it's going to be concave up, but it's also confirmed by the points we've chosen.